So in this section, we are going to be looking at compressor types, and their applications. So we are going to introduce ourselves to the working principles, the various components, and how they interact with one another to produce whatever the compressor is meant to produce. That is the compression of the air. So we are going to stick to the fundamentals, the basics in this section. So, but before we go into it, we want to define or try to understand what a compressor is. So as you can see on your screen, a compressor is a machine that increases the pressure of gas by reducing its volume. Remember, in the case of pump, we said the pump actually helps in transferring liquid from one point to another by increasing its pressure. So the pump actually handles non-compressible liquid. Okay, it handles liquid which are non-compressible fluids. But in the case of compressor, they handle compressible fluids, and from the way they function, they reduce the volume of the air in this case, or the gas, okay, or the compressible fluid. They compress it to increase its pressure. So with that, it could either be stored as such, or because of that compression energy that has been stored in it, it could be transferred to another point in your facility. So the compressor handles compressible fluids, while the pump handles non-compressible fluids like liquid, while compressor handles gas. Okay, so the basic function is to increase its pressure by reducing its volume, and with that, it could be sent into your facility or sent for storage. So we are going to look at some of the reasons why we need to increase the pressure of the fluid, now the compressible fluid or gas. Okay, so here is first one is to help to transport the gas through pipeline. So as you compress the gas, like we said earlier, the pressure will have increased, and that increased pressure is increased kinetic energy that will assist in moving the gas from one point in the pipeline to the other. Then the second one is to help to deliver the necessary pressure that is required in your process. Okay, so if it is compressed air, or compressed air, maybe for instrument air, we need to deliver that air to the facility or to our process at certain pressure. So it is the compressor that will definitely assist us in raising the pressure of the gas. Then thirdly, to deliver the correct pressure for storage when we want to store the compressed gas. Okay, for us to have it either in the liquefied form, we have to compress it to a level, like in LPG. We have to compress it to a level for it to remain in that liquefied form, so that we can conveniently store them in vessels. Then, like we said earlier, to turn the gas into liquid, and for combustion, as we saw in the case of your gas turbine, the compressor section actually compresses the air, the combustion air, before it is sent into the combustion chamber. So we can have it as such, or certain chemical reactions, they can only take place at certain pressure. So it is the compressor that can compress the gas to send or to generate that pressure that we actually need, and also to provide a source of stored energy. Remember, we said earlier that as it is compressing the gas, it reduces its volume, increases its kinetic energy. Okay, so that stored kinetic energy can be used for several purposes, as you can see on your screen. Okay, so as compressed air to drive power tools or electric motor, and as we saw earlier in the case of our pump, the diaphragm pump, there are some of them that operate with compressed air, and of course for instruments, as we said earlier. So we are going to look at the types of compressors that we have, that we come across in the industry. So we are going to categorize them into two broad categories. Yes, the first one is the dynamic compressor. So as you can see from the name, the dynamic compressor actually exerts some force on the gas molecule, okay, to increase its kinetic energy. So that kinetic energy, as we'll see later, will then be converted into increase in pressure when we apply the Bernoulli's principles. Then the second is the positive displacement compressors. Okay, so in this arrangement, you can see we have a piston and the rod that is connected to the piston. So as the piston is moving to and fro, it compresses whatever that is contained in the chamber, okay, the cylinder, and that increases the pressure, and that will be discharged as increased or compressed gas or compressed fluid. So in the case of the dynamic compressor, you can see that we have an impeller that helps to accelerate whatever gas that comes into it through the eye of this compressor, or the inlet of this compressor. So we'll see later how all of them functions. So in the dynamic compressor, we are going to be looking at the centrifugal compressor. Centrifugal compressors. Okay, so in the centrifugal compressor, we have the major compressing element as the impeller, as you can see here. Okay, so as the impeller is turning, it creates a reduced pressure at the suction end, and that will drag in the gas. So that gas molecule, as you are seeing here, the impeller, since it's turning, it will accelerate the gas molecule. Okay, so as it's leaving the impeller, it will be leaving with increased kinetic energy. So which means that its velocity will have been increased by the impeller. So as it comes to the circumference of, that is the casing of the pump, that increased kinetic energy or high velocity fluid molecule or air molecule or gas molecule, okay, as it strikes on the wall of the compressor casing, it is momentarily stopped. That is, the velocity is reduced. So when you apply Bernoulli's principles, you will see that that reduction in velocity will now be converted into increased pressure. Then the volute shape also is designed so that as the volume is increasing, okay, as it's moving out, that will also help to increase the pressure further as it is going out of the compressor. So that is how the centrifugal compressor helps us to achieve our purpose of increasing the pressure of the gas. Okay, that is, the impeller, as it is turning, it creates lower pressure at the suction end. That lower pressure drags the gas in, and then as it comes in, the impeller, you see that there are vanes on the impeller. These vanes will now accelerate or add kinetic energy to the gas molecule, So that fast moving gas molecule, as you can see here, on impinging on the walls of this casing, they are momentarily slowed. And in applying Bernoulli's principle, that reduction in velocity will cause an increase in pressure. So whatever that will be coming out from the discharge here will be of increased pressure, or the pressurized gas. So this is the complete unit of a centrifugal compressor. This is the driver, is electric motor driven, and this is the gearbox. Okay, and here we have the compressor itself, centrifugal compressor. This is the suction end that is attached to the suction piping. That is the source of your gas, and then this is your discharge end. Okay, that is tied to your discharge piping, to your process or to storage, whichever. So that is how the centrifugal compressor functions. And this is the main active component, which is the impeller. Okay, you can see the vanes on the impeller. These are the parts of the impeller that helps to accelerate or add velocity to the gas molecules. So, as you see, all of them, they have their function. So if anyone is missing, that can reduce the efficiency of your compressor. So we should put this at the back of our mind, okay? The function of each and every component, especially the active ones. So what we have just described is a single stage compression. So we can have it in multiple stage, as we discussed in the case of the centrifugal pump. That is, the compressed gas can be sent into stages containing different impellers. Okay, so as it is taken from the atmosphere or from your source through the air, it is accelerated, compressed, or the pressure increased, and then that is now sent to the second stage, to the third, the fourth, and the fifth. Are we getting it? So at the end of the day, you have a highly compressed gas, okay, which will be many, many times higher than what came in pressure. So now this is the multistage centrifugal compressor. You can see this is the intake filter. Okay, so this is the suction end, and this is the discharge end. So this is the driver, the electric motor. Okay, so you see that it is supported at both ends by bearing, and then we have the shaft seal at both ends of the shaft before the bearing. So all of these, they are very important components in the compressor. So what are some of the advantages of this kind of compressor and their application? So one, it has a very high flow rate. Okay, so it can deliver great volume of compressed air per unit time. Then it is also very efficient in the handling of large gas volumes, unlike the others. Then it's also fit for continuous operations, since the component and the component arrangement is very simple, okay, and rugged. So it is fit for continuous operation, and because of the simplicity, the maintenance too is relatively low. So, and it's also suitable for very high pressure applications. So here is highlighting some of the components as we discussed earlier of the compressor. So this is the major active component, which is the impeller. This is the main shaft. Okay, we have the two sets of bearing. Here we have the journal bearing and then the truss bearing. So the general bearing basically is to take care of the radial movement of the shaft, and then the thrust bearing is to take care of the axial movement or thrust movement of the shaft, because as it's rotating, there's bound to be that axial movement. So the axial the thrust bearing is there to assist it, okay, for smooth movement in the axial direction. So like we said earlier, we have the shaft seal. We have the shaft seal, which could be dry or wet. Okay. In most cases on this multistage, we use the labyrinth seal. You find the labyrinth seal. Okay. So these are the major components that you will see on the multistage centrifugal compressor. So the next that we'll be looking at is the, still in dynamic compressor, is the axial flow compressor. Remember, in the centrifugal compressor, the gas or the gas molecule is accelerated away from the center towards the circumference of the impeller. Okay, so that is why it is called centrifugal, because of the centrifugal force away from the center towards the circumferences. So, but in this case, the gas is moved in the axial, that is along the axis, okay, of the compressor shaft. Are we getting it? That is why it is called the axial compressor. So as you can see here, we have multiple blades. So each of these blade sets, both the stationary and the stationary blade, which is on the stator or on the frame of the compressor, and then the rotating blade, which is on the rotor, both makes a stage. Okay, so what actually happens here is that as the rotor is turning, that creates that reduced pressure, okay, that drags in air from the atmosphere or from your source, or gas from the atmosphere or from your source. So that gas molecule is accelerated by these sets of blades, and this acceleration is done towards the stationary blade. Okay, so here again, the stationary blade will serve as will serve to, that is, will reduce the velocity that the incoming gas is already having, by virtue of the fact that the rotating blade is pushing it. Okay, so that temporary stoppage, like we said, with the application of Bernoulli's principle again, will result to an increase in pressure. So this diffuser, which is the stationary blade now, okay, this stage, as it is leaving this stage, the gas will be increased, the gas pressure will be increased to a level. Then it will come to this other stage again, which is the set of this stationary and rotating blade. Okay, and then it will be increased further. So you see that the gas pressure will be increased along the shaft axis as it's moving away. So what will come out here will be an increased pressured gas. Okay, so if you look at it, you'll see that the will be an increased pressure gas, and this is what we have here too. So these are the stationary blade on the bottom part of the casing. This is the rotating blade. So we also have the upper part, okay, of the casing that covers it. So the difference is that the centrifugal compressor is compressing towards the radial direction, while the axial flow compressor is compressing towards the axial direction of the compressor. So this is a coupled unit. Here we have the steam turbine driver. Here we have the gearbox, I think. Here we have the gearbox, and this is the compressor, okay, that will help deliver compressed gas. So what are some of the advantage and application of this compressor? It has a very high efficiency and pressure compression ratio. Okay, we saw the arrangement, so that actually enhances the compression ratio. So it is also small. Okay, you see it. Imagine you having these multiple stages of centrifugal compressor. That will be bulky compared to the axial compressor. So it is compact in size when you compare it with the centrifugal compressor. It also has a very high flow rate and is suitable for high speed operations. That is why it is readily applicable in gas turbines, okay, as we'll see later. So some of the application is in gas turbines. You know, in the gas turbine we have the compressor section, we have the combustor and the turbine section, okay. So the compressor section is what will deliver the compressed air to the combustor. So and that is what we have here. Okay, so this is the compressor section. This is a gas turbine. So this compressor compresses the air that is coming in and deliver that compressed air to the combustor. This is the combustion chamber, and it is ignited here, burnt before it is sent to the gas turbine to result to this kind of movement that we are seeing here. Okay, so it has very wide application in aerospace and also in the industry to drive power generators, to also drive compressed air to help to produce compressed air and to drive compressed gas through gas pipelines. Okay, so it has that also in the chemical industry to provide compressed air and compressed gases, okay, as the case may be. So we'll now move to the positive displacement compressors. So the positive displacement compressors, unlike the centrifugal compressors or the dynamic compressors, both the centrifugal and axial, what it does is that it reduces the volume of the gas, thereby increasing its pressure. So with that pressure, the gas can, that pressure and increased stored energy, the gas can travel some distance within your facility. So the first that we are going to be looking at is the reciprocating compressor. So the reciprocating compressor, as you see here, have a piston, okay. So that reciprocating movement, the to and fro movement of this piston will be what will be compressing the air and be sending. So let's assume that this is our compressor now. Now this is the piston, okay. So this is the crankshaft. This is a crankshaft tied to your driver. So the crankshaft together with the piston, this connecting rod, will convert the rotating mechanical motion from your driver into this to and fro motion or movement that we actually need, or reciprocating movement that we need, okay. So as the piston is moving up and down, it is increasing and decreasing the volume. So let's assume that this is the intake section, because you can see air filter here. So as it is moving down, the pressure within this cylinder will be reduced, and that, since it's reduced, the pressure will now be less than the pressure outside, and that will open up the suction valve, and air, in this case now, air will be administered into this chamber. So as air is administered, when it gets to the bottom dead center, it will start returning. So as it's returning, it will be reducing the effective volume of this cylinder, and that in effect will cause the compression of the air molecule or of the gas molecule and increase its pressure. So the pressure will be increasing up to a stage, and then the discharge valve will open up, and then the gas will come out as with that increased pressure as compressed gas. So that is what we are seeing in this animation. Okay, so as it's moving away, pressure reduces, intake pressure reduces, air is intake, the intake valve opens up, air is administered, okay, or admitted into the chamber. Then as it's compressing, the pressure is increased and then discharged. So it's as simple as that. So that is how the reciprocating compressor works. Okay, so here we see all the components as we discussed earlier. Okay, the intake valve and the discharge valve. This is the piston, and then we have the, as we have it in normal reciprocating engine. Okay, the oil rings, the wear rings, and the compression ring. Okay, so this is an example of a reciprocating compressor in the field. This is the driver, and this is the one end of the compressor. Okay, we have the intake valve, could be plate valve, and the discharge valve. Okay, that is discharge, then sent to, since it is two stage, there's another stage here, sent to the intercooler before it is sent to the second stage for further compression. We'll get to see all of this later. So this is a double acting reciprocating compressor, I mean to say. Okay, so you see that it is compressing at both ends. So it's like you having two single acting reciprocating compressors. Okay, so when here is compressing, here is administering gas into this chamber, and then as here is compressing also, here is administering. Okay, so you see that that will help to stabilize the pressure here, unlike when you are using a single stage, a single acting reciprocating compressor. When you use a single acting reciprocating compressor, the pressure at the discharge will be pulsating, but with a double acting, the pressure will a little bit be stabilized. Are we getting it? So we have it could be discharged into a vessel to stabilize the pressure before you send it into your process anyway. So this is what we have here, and that is the type we have here. You see that we have double acting reciprocating compressors on both ends of this, and this is where the driver is attached to this particular driver. That is the crankshaft, and this is the connecting rod, okay, to the piston. So this is one chamber and this is the other chamber. It compresses, discharge, and then once it's returning, it compresses, discharge. Okay, so the intake air comes in here and also here, similarly here. So once here is compressing, you see that both sides will be delivering compressed air almost simultaneously. So with this arrangement, you see that the position, especially since both of them, okay, this one is delivering, this one will compress and then send to this to increase the compression ratio of the compressors. Okay, so which means that invariably what it's looking like is that we have a two-stage compressor, because here we compress and send to this, okay, for further compression. So that's the double acting compressor, and that is what you are seeing here. You see the piston as it's moving away, here opens up, administered, then compresses, okay, and then it is discharged. Okay, then it is discharged. Then here too opens up as the piston is moving away, moving this direction. Then as it's go returning back, it compresses the air, and then here opens up, it is also discharged. So that's the double acting reciprocating compressor. So what are some of the key advantages of these types of compressor? One, it has a very high pressure capability. Okay, so it could be used in high pressure environments where you actually need high pressure. Then it has the ability of handling a very wide range of gases. So that means that it could have a wider range of application also on various gases. So and you can also use it in various operating conditions. Okay, then the flow can be controlled, especially when you have stabilization vessel in there. So the next that we'll be looking at is on the positive displacement compressor is the screw type compressor, rotary screw compressor. So here you see the two meshing screw gears. Okay, so as they are turning, you see here creates like a pocket that traps the incoming air. So that trapped air, as it is moved away from the suction, okay, the volume is reduced, and that increases the pressure until it is eventually discharged. Okay, so that is what you will see in this animation now. See incoming, and then as it's going, the pressure, the volume is reduced. That increases the pressure, and then the increased pressure gas is sent to the discharge or the outlet. So at the end, we will now have a compressed gas coming out. So you see how compact it is. This is a complete compressors. Okay, so this is a complete unit also. You can see how compact it is. This is the intake, that's the air filter, okay, into the compressor, discharge into this vessel to help stabilize the pressure. So some of the key advantages of this type of compressors include very high efficiency. It is fit for continuous operations also. Then the maintenance too is very low because of the rugged components that we have. Okay, then the design is compact, as we said earlier. Then the operations is very quiet, so you see them in refrigeration, air conditioning units. Okay, the operations are very, very quiet. Then still on the positive displacement compressor, we are going to be looking at the rotary lobe compressor. So here we have the lobes, okay, as it's turning, traps air or traps the gas, subject to reducing volume, thus increasing the pressure, and then it is discharged as a highly compressed gas. Okay, so that is what you are seeing here. Traps the air or traps the gas, okay, and as it's moving, reduce the volume to compress it and then discharge. So this lobe is compressing while this one is also compressing simultaneously. So that helps to reduce the pulsating effect if it were to be only one lobe that is doing the compression. So this is the rotary lobe compressor. Okay, that's how you see it also in the field. So what are some of the advantages and application? So they have very high volumetric flow rate. They can handle dirty or dusty gases. So they have low noise level, as we said on the rotary screw compressors. Then they are also very simple in design. Okay, you will also see them in air conditioning and the refrigeration application. So still on the positive displacement compressor, we are going to look at the diaphragm compressors. So in the diaphragm compressors, the major active element, okay, or compressive element is the diaphragm. So the to and fro movement of the diaphragm helps to reduce and increase the pressure in the area. So you see this is the diaphragm, this yellow, okay. So as it's moving away, that reduces the pressure, that opens up the suction valve, administer gas into this chamber, and then as it's moving out, it compresses it. That increases the pressure because we reduce volume, and the discharge valve opens up. So that is what we are having here now, okay? Suction, discharge into this particular vessel. So here we have the oil cooler.